Good afternoon, everyone, and welcome to our lunchtime webinar. It's to dive a little bit deeper into the recently published report from the Acorn Hydrogen Project, titled Hydrogen in Scotland, the Role of Acorn Hydrogen in Enabling UK Net Zero. My name is Kirsty Lynch, and I'm the Communications Director for Pale Energy, which is an independent low-carbon technology business headquartered in Banchory in Aberdeenshire. And we're the leading developer on the Acorn project. So today I'm going to be your host for this webinar. So let me start by introducing all the experts that we've got lined up for you this afternoon. Today you're going to hear from Mark Taylor, who is the Deputy Director for Energy Innovation at BEIS within the UK government. From Tim Dumenil from Acorn Hydrogen, he's the Acorn Hydrogen Project Manager at Pale Energy, and Silvian, Baltac and Emrah Durusut from Element Energy, and they are the key authors of this report. If you can move to the next slide, Emma, please. Just to give you an idea of how this session is going to run, we've got a 45-minute webinar and the presentations will run to around about 12:30, and then we've got time for a few questions to our experts at the end. We're going to be recording the webinar, so if you know of people who have been wanting to join us but haven't been able to this afternoon, then you can forward on the link. We will send the link to the webinar once it's been put up onto our website. We'll send it around to everyone who's registered, and you can see it live on the website shortly, at some point next week. If you get any questions, it would be really helpful if you could submit them during the presentations, and that's just to allow me enough time to get through as many of them as we can at the end of the webinar. And let me just show you really quickly how you do that. If you can move to the next slide. Thanks, Emma. So first off, you just need to find this little icon. It should be at the top right-hand side of your screen. When you click on that, this nice sidebar should appear, and in here you can type any questions that you have, or any nice comments are always welcome. And just click on the button and that will send it straight through to me, and I'll monitor the Q&As as they're coming in and put them to our experts at the end. Right, we've got a hard stop at 12:45, so I'm going to get cracking now and hand over to Mark Taylor, who's going to give a little bit of context about some of the support that is already available for hydrogen within the UK. Mark, over to you.
Thank you, Kirsty. I'm absolutely delighted to be here on behalf of BEIS. Acorn we've supported for many years, and it's really fantastic to see this project move towards deployment. When we first interacted with Acorn, it was very much a research project, so it's really exciting to see it progress. Now, the reason we're interested in this is because in the UK we have the Climate Change Act, which is a law requiring decarbonisation of the UK. Originally it was set to 80% of greenhouse gas reductions, but last summer it was set to net zero by 2050. The Act requires that we cap greenhouse gas emissions over a carbon budget period, which is 5 years. So that means rather than just saying net zero by 2050, we actually need to start decarbonising right now, and we need to keep making progress, and that progress is monitored by the Committee on Climate Change. Next slide, please. So BEIS sees hydrogen as a key enabler for achieving net zero, but a hydrogen pathway involves a full chain, everything from production, transmission, distribution and end use. And actually storage is seen as a key aspect of enabling hydrogen to be able to be a stable energy system. I've shown you a number of competitions that I'm running. So the ones in blue include the BEIS Low Carbon Hydrogen Supply Competition, of which this Acorn project is funded, and then some applications downstream. So one is Hyperheat, which is looking at domestic appliances and safety in the home, and the second one is industrial fuel switching. Our survey of industry has established that hydrogen will be a key enabler for decarbonisation of many industry, and we're very keen to start demonstrating that. We work closely with Ofgem, who are working with the GDNOs, looking at transmission and distribution. A secondary stream of work, which is very important in the context of Acorn, is our funding of CCUS research. And that includes a CCU demo, which is happening at the moment in Tata Chemicals in Cheshire, which will capture 40,000 tonnes. And we're doing further work, again with ACORN, amongst other programs in CCUS innovation. The key thing that we're looking to achieve is we're looking to innovate, and now we're looking to start deployment, and we see ACORN as a fantastic opportunity for that. Next slide, please. Just to give you some more detail on what we're looking in hydrogen supply. So you can see on the list on the left, you've got pale blue dot in the middle, which is the Acorn Hydrogen Project, and you're going to hear much more about that from Tim following me. But we're also looking at other GHRs, one in the HyNet project in the northwest, looking at an alternative to GHR, a process from GTI in Cranfield. We're also doing a significant amount on green hydrogen as well. So we're looking at scaling up electrolysis. And the third one, which is of particular relevance to Scotland, is looking at using offshore floating wind to produce hydrogen offshore and then allowing us to pipe hydrogen onshore rather than electric power. So this just shows you the power of hydrogen. It enables so much technology and innovation, and how a project like ACORN is so critical to enable that. Next slide, please. And then a further thing we need to develop is it's all very well to talk about making hydrogen. It's very important that you have companies that can use it and can use it safely and in a way that delivers the same quality of product that they currently achieve. So we're currently doing 4 projects in industrial fuel switching. It isn't exclusively hydrogen, but it's heavily dominated by hydrogen. And the applications include glass, lime, cement, and the food industry. So we're really trying to push hard and demonstrate that hydrogen can be effective as an industrial fuel. Next slide, please. And on the domestic side, we now have hydrogen cookers and hydrogen boilers. Both Bosch and Baxi have produced hydrogen boilers for us. And we've done this in a way that we're ready to start a trial in the next year or two. And in fact, if you watch out, next year at COP26, we'll be displaying these hydrogen appliances. We've also made significant progress on the safety case for hydrogen in the home. We're currently working with HSE to get that approved for us to be ready to do a trial. So hopefully that shows you that with BEIS's work, we've started to build momentum so we can actually start the rollout of hydrogen, start demonstrating it and start using it and start contributing to those carbon budgets. Next slide, please. So as I mentioned, we've supported ACORN from research through to deployment, and we see it as one of our flagship examples of how BEIS can be effective, supporting initially through ACT and now through our CCUS innovation competition and our low carbon hydrogen supply competition. The good news is that the Chancellor has already announced that we can continue this in the next spending review, and in fact our programme will double in size. So for those of you who are watching and interested in innovation in this space, you can anticipate next year we will start to launch another round of competitions in order to progress this agenda. Meantime, it just leaves me to hand you over to Tim to tell you more about the Hydrogen ACORN project, and I wish you a pleasant seminar.
Thanks, Mark, and good afternoon, everyone. So if you can move on to the next slide for me, please, Emma. So the ACORN project will be located at St Fergus in Aberdeenshire, and the St Fergus gas terminal currently processes around 35% of the UK's natural gas demand, with close proximity to CO2 storage locations, making the St Fergus location an ideal hydrogen production hub. The conversion of hydrogen into power and heat at the point of use is then free from any CO2 emissions. Currently, there are 2 key elements to the ACORN project under development. Firstly, establishing carbon capture and storage infrastructure, and secondly, the generation of hydrogen from natural gas. The project is initially planning the construction of a 200 megawatt hydrogen production plant that could become operational at the end of 2025. To fully convert all of the natural gas flowing through St Fergus into hydrogen would require gigawatts of reformer capacity to be installed. The emissions from the hydrogen production would be captured, transported and safely stored in the central North Sea, reusing current oil and gas infrastructure enabled by the sister project ACORN CCS. So the Acorn Hydrogen Project is one of the key large-scale hydrogen projects on the UK path to net zero. The project is highly scalable due to the large volumes of natural gas feedstock available, the massive offshore CO2 storage capacity, and the availability of existing offshore pipeline infrastructure. Next slide, please, Emma. So Acorn Hydrogen is a really important part of the Acorn family. It's being very actively developed by Pale Blue Dot and our technical study partners, Chrysaor, Shell and Total. We know that hydrogen is a clean burning gas at its point of use, which is really helpful for UK emissions reductions. So by creating hydrogen from renewable energy or from natural gas with the right infrastructure in place to deal with the CO2 emissions, we can then begin to tackle some sectors that have traditionally been very tricky to decarbonise. So Acorn Hydrogen will make use of the natural gas coming into St Fergus and the CCS infrastructure to be established at the same site. And by the end of 2025, we aim to have a full chain 200 megawatt hydrogen production plant up and running to enable an initial 2% hydrogen blend by volume into the national transmission system, the NTS. The plant would be delivering carbon-free fuel through the permanent sequestration of 400,000 tonnes a year of CO2 via Acorn CCS. So hydrogen is already being used as a low carbon energy source for all sorts of applications along the east coast of Scotland, and building this market and the infrastructure to support it is key. Much of the UK's local distribution networks, the local pipes that actually connect to your house, are already capable of delivering high purity hydrogen to heat your homes. So in time, we expect higher percentages of hydrogen to be safely blended into the NTS and other routes to market developed that together would see Acorn Hydrogen scale up to meet its ultimate aim of a 100% hydrogen network. Thank you, Emma. So Acorn Hydrogen is currently evolving 4 routes to market for the supply of hydrogen. Firstly, the basis of design for the project is the initial 2% by volume into the NTS. Secondly, started 2 years ago, the Aberdeen Vision project is a collaborative project between SGN, National Grid and Pale Blue Dot Energy, assessing the potential for hydrogen export and hydrogen applications based around hydrogen production from the Acorn Hydrogen Project at St Fergus. The project was supported by DNV GL and ERM. And SGN are progressing plans to have a new dedicated pipeline in place for 2025 that runs from St Fergus to Aberdeen to deliver high purity hydrogen to pressure reduction stations connected to the low pressure transmission system. And the Aberdeen Vision pipeline seeks to move all of Aberdeen to an initial 20% blend of hydrogen as Acorn Hydrogen becomes operational. And the aspiration is then to convert all of Aberdeen and Aberdeenshire to 100% hydrogen by 2030. The third route to market we're looking at is the Peterhead Power Station, which currently receives natural gas via a dedicated pipeline from St Fergus. And the Acorn project is reviewing with SSE their decarbonisation options, which include the potential to deliver an increasing hydrogen blend to one or more of their gas power generation turbines. And finally, the Acorn team have just commissioned a high-level study to evaluate the option for road tankers or tube trailers to supply either compressed hydrogen, ammonia, or LOHC, or liquid organic hydrogen carrier. And this could enable large energy users to expedite a move from 20% to 100% hydrogen ahead of the pipeline network transition. And this supply route could also enable current off-grid gas users to switch fuel from diesel, kerosene or heavy fuel oil to hydrogen. So the development of multiple routes to market in Aberdeenshire further stimulates hydrogen demand, not just for the northeast, but for Scotland as a whole. Thank you, Emma. So to understand the role that Acorn Hydrogen could play in delivering hydrogen in Scotland and the project's overall contribution to UK net zero, Element Energy were commissioned to complete a socio-economic assessment on the potential hydrogen growth scenarios for Scotland. And so I'll now hand over to Silvian Baltac of Element Energy, who will provide you with a brief summary of the key findings from their Hydrogen in Scotland report. Thank you, Silvian.
Okay. Thank you, Tim. Good afternoon, everyone. I'm pleased to be here. Like Tim mentioned, the Element Energy was commissioned to analyze the potential for Acorn Hydrogen in Scotland and the socio-economic benefits of the deployment moving forward to 2050 and how it could deliver net zero in Scotland. So before we dive into the details, I'll just give a quick overview of what we do. Element Energy, as you may know, is an international consulting firm focused on the low carbon energy sector. I work on the CCUS and industrial decarbonisation team with my colleague Emrah, who will be joining the panel shortly. We cover all areas of the energy sector, including energy networks, smart energy systems, hydrogen, low carbon transport, and built environment. We advise both public and private clients on matters of energy policy, energy technologies, energy strategy. So if you have any questions about your issues around energy or questions that you'd like answered, feel free to contact us. And of course, if you have any additional questions around the study findings that will be presented today as well, please feel free to email us to further discuss those. So now, if you could move over to the next slide, I'll just give a quick overview of the key findings from our study. So first of all, we looked at the hydrogen and the potential for hydrogen in Scotland and how hydrogen could help Scotland decarbonise and reach net zero by 2045, which is the local target in Scotland, but also the wider UK by 2050. So as mentioned earlier, there are multiple applications for hydrogen that our study considered, and on this slide I would just like to highlight some of them. So as Mark and Tim mentioned earlier, industry could use hydrogen by replacing natural gas with hydrogen, which would reduce the emissions as a result. Transport could use hydrogen for long distance heavy duty vehicles where electrification may not be possible. Hydrogen could play a significant role in decarbonizing heat in commercial and domestic establishments and dwellings by replacing natural gas through a grid conversion to hydrogen. Initially, it will likely be a mix and blending of hydrogen into the natural gas grid, further going to full conversion. And then lastly, power generation can also benefit from hydrogen by replacing natural gas feedstock. So those are the roles that hydrogen could play in the net zero, and those have been identified as critical by the Committee on Climate Change. Our report looked at 3 scenarios, so if we can go to the next slide. Yeah, so on this slide, we show the 3 scenarios that we examined in our study. So in order to understand the potential for hydrogen and Acorn Hydrogen in Scotland, we derived 3 scenarios. All those 3 scenarios start from the initial deployment of the Acorn Hydrogen that Tim highlighted earlier, that at St. Fergus by 2025, you will have hydrogen production using steam methane reforming and potential blending into the NTS. All scenarios expand from this initial step and consider different roles, geographies, and scopes and ambitions for hydrogen in Scotland. In the first scenario that we call regional growth, we consider a regional role in which hydrogen is used regionally around Aberdeen to decarbonise the gas grid in Aberdeen as part of the Aberdeen Vision project highlighted earlier, the Peterhead power station around St. Fergus, as well as the transport around Aberdeen and any of the industry. In addition, in the first scenario, we also consider regional growth for regional role for hydrogen in decarbonising industry in Grangemouth, in the decarbonizing the heavy industries there by locally producing hydrogen there and enabling capturing of the emissions to the Acorn CCS project by reusing some of the existing infrastructure, particularly the feeder tank pipeline that goes from Grangemouth to all the way to St. Fergus, and then sequestrating the emissions in the North Sea using the common infrastructure with Acorn. The second scenario that we examined covers all the sectors that would use hydrogen in the future, and that would be commercial and domestic heat, industry, power generation, transport, but would cover all of Scotland. So by 2050, our scenario examined the potential for Scotland to turn into a hydrogen economy where all the sectors would be using hydrogen. This scenario assumes that hydrogen will be produced at scale in Scotland through a wide variety of sources, using both blue hydrogen from natural gas with CCS, but also renewable hydrogen made from electrolysis generated by using electrolysis with renewable electricity. So in this scenario, hydrogen will be taken at a much higher level of around 72 terawatt-hour per year, will be produced in several locations, and the full supply chain will require a wide deployment of infrastructure, including pipelines that could connect the different towns in Scotland and deliver hydrogen, as well as a pipe that could potentially go all the way out to north of England and connect the rest of the UK with hydrogen potentially produced in Scotland. In the third scenario, we assumed an even higher potential for Scottish hydrogen that builds onto the second scenario. So in the third scenario, we have a Scottish hydrogen economy, which has scaled up its hydrogen production so that it also allows exports to other regions. So there will be extra capacity in Scotland to produce hydrogen that could be delivered to the rest of the UK or to continental Europe, markets that have similar net zero targets as the UK, and that would require this hydrogen by 2050. And this is especially fitting very well with the hydrogen strategy that the European Commission announced a couple of months ago, where Europe is on the goal to decarbonize and use a lot of hydrogen to cover to decarbonize industry and transport and other sectors, and that Scotland could leverage on that potential by exporting some of the hydrogen to Europe. So those are the scenarios that we examine in our study, and more details are provided in the report. But if we can move to the next slide, I would just like to highlight that those scenarios build on the initial deployment of Acorn Hydrogen and explore different commercialization routes that he mentioned. So as you see here, in all scenarios, we start in the early 2020s with 2025 grid injection of hydrogen into the NTS, and then building on other potential uses for hydrogen, including Aberdeen, including transport, including the Peterhead power station, and so on. So in the early years, we see Acorn Hydrogen as having a really essential role in kickstarting a hydrogen economy regionally, but then also going forward at a wider scale in Scotland and helping other hydrogen projects develop by supplying learnings, but also critical infrastructure. So on the next slide, we highlight further why we think that Acorn Hydrogen could represent an early opportunity for kickstarting this hydrogen economy in Scotland. So first of all, and like Tim mentioned earlier, Acorn Hydrogen is using current assets and mature technologies. The project is proposing to repurpose some of the oil and gas assets in the North Sea, thus reducing the cost of the project, but also reducing the timeframes, such that hydrogen could be produced by 2025 and injected into the gas grid, and then moving onwards to the wider Aberdeen region by 2030 via dedicated pipeline. That would allow full conversion of the gas grid in Aberdeen and conversion, uptake of hydrogen in the transport sector. Then from Aberdeen onwards, hydrogen could expand to a Scottish level, such that all sectors could potentially use hydrogen in Scotland. Gas grid running on hydrogen in Scotland would become viable in the 2030s and 2040s, allowing Scotland to reach its net zero target by 2045. If we move to the next slide, as part of our study, we also try to understand what would be the benefits of this deployment beyond delivering emission reductions and wide uptake of hydrogen. So our analysis consists of a techno-economical assessment that analyzes the potential value that this project and the deployment of hydrogen infrastructure, the deployment of the supply chain, the conversion of the gas grid, and so on, would add to the UK and Scottish economy. So depending on the scenario, we estimate that between 8.6 billion and 22.5 billion pounds could be added overall between 2020 and 2050 as gross value added to the UK economy. As I mentioned earlier, all scenarios assume a high deployment of infrastructure under the form of pipelines, under the form of steam methane reformers, electrolyzers, and so on. That would require, of course, people to install and build this infrastructure. So our analysis also estimated the benefits in terms of jobs that would be created as a result of a Scottish hydrogen economy that could be kickstarted by Acorn Hydrogen. At the peak of the deployment, which varies between scenario between 2036 and 2040, we estimate that between 13,000 and almost 29,000 people would be employed in activities related to building, designing, and commissioning the infrastructure, as well as operating some of the early infrastructure that has been deployed. When it comes to long-term benefits, we estimate that by 2050, between 2,500 people and 7,700 people would be employed in activities related to the maintenance and operation of the hydrogen infrastructure that would have been built within the next 30 years. So here we see that Acorn Hydrogen has the potential to deliver a wide amount of employment and macroeconomic benefits within the next 30 years. And on the side, we highlighted some of the industries that will be supported. And as you can see, the list is quite long, and I will just highlight 3 of them. So of course, construction and civil engineering would be one of the key industries that will benefit from this, as they will be in charge of deploying and constructing and designing all the infrastructure. Machinery and metal products, of course, will also be quite essential to this deployment, and this is why one of the reasons why Scotland and the UK and in general a supply chain of hydrogen materials and equipment would have to be established. And thirdly, oil and gas skills could also be used in this transition, and I'll be touching on to those in the next slide. So on this slide, we highlight the fact that apart from delivering economic benefits, Acorn Hydrogen has the potential to also bring other socioeconomic benefits, such as it could enable long-term growth. As mentioned earlier, it utilizes current infrastructure, generating significant cost savings. At the same time, it could leverage on regional oil and gas skills, which are very present in Scotland and particularly around Aberdeen. And those skills can be repurposed for the deployment of hydrogen and CCS infrastructure that would require similar kind of skills to those currently used in oil and gas. This will enable local communities to be part of the energy transition and not be left out as a result of oil and gas operations reducing in time as a result of the reduction of greenhouse gases. So there's potential for the local communities to actually build on this project and develop a new set of skills which are comparable to those that they have today to be able to move forward and still have a prosperous community in Scotland and around Aberdeen. Thirdly, in terms of long-term growth, Acorn Hydrogen and the subsequent hydrogen projects that will be deployed could position Scotland as a leader in trading hydrogen services through the skills that I just mentioned, but also products such as ammonia and other hydrogen carriers that could be traded and exported to Europe or other parts of the UK. In addition, Acorn Hydrogen and the offset of a hydrogen economy in Scotland could catalyze net zero. Acorn Hydrogen, particularly as a very early project with the potential to scale up within the next 5 years, will set up a key infrastructure in place that would enable both the Grangemouth industry to decarbonize, so that the Grangemouth industry will have access to storage in the North Sea, where the emissions could be captured and stored safely, but also would provide future blue and green hydrogen projects with access to essential infrastructure that they can use in the future and build upon. And one example of this would be the gas grid that Aberdeen Vision Project and Acorn would help deliver by in the early 2030s. That will be the first step in setting up a key infrastructure that can then be expanded such that one day by 2050, all of Scotland could be fully converted to hydrogen instead of using natural gas. And the third and last point that I wanted to make is around the skills and knowledge. Of course, we mentioned that Aberdeen and Scotland has a great potential to convert its current oil and gas skill base into skills suitable for the net zero world and for the energy transition. At the same time, it also has the potential to export those skills and knowledge to other parts of the UK who may be looking to implement similar hydrogen projects. And like Mark mentioned earlier, there are quite a few projects underway, as well as export those skills to other regions, particularly to Europe, where they will be beneficial. So within the past 15 minutes, I was trying to quickly summarize some of the key findings of the report. There's a lot more information out there in the report that you can check out on the paleblue.org website, on the Element Energy website. Our report covers all the scenarios, all the demand sectors that we consider, and there's a lot more information around the benefits and the job implications of the scenarios. However, I think my time is running out, so I will be happy to answer any of your questions in a few minutes, and then I think I will pass now to Kirsty for the panel discussion. Thank you.
Brilliant. Thanks very much, Silvian, Tim and Mark, for that whistle-stop tour. We have had 336 people sign up to the webinar, so I'm going to just crack right on so we can try and get through as many of these questions as we can. They've been coming in thick and fast during the presentations. So if our panelists are all ready, I'm just going to take a minute to remind people how to submit the questions, although it seems like there's been no problems so far. So just a reminder that there's that button on the right hand side, and it should open up the Q&A panel there on your right, and just submit your questions through. Right, if you're okay, I'm going to start our Q&A session with Emrah. So we've not seen you so far, Emrah, so if you don't mind sharing your video just for a second or two so that people can see your face, make sure you're not in your pajamas. That would be fantastic. And I'm going to ask you, what recommendations did you have in the report to come up with? Basically, what recommendations did you have for progressing the hydrogen industry here?
Thanks, Kirsty. Yeah, luckily I had a shirt today, so that was good coincidence. I don't do that every day during the lockdown. Anyway, great question. So what I would like to do is I would like to talk about a couple of enablers. The previous presentations were excellent, highlighting the importance of ACORN, but also how this initial phase of ACORN can be scaled up, and then a significant hydrogen economy could be developed in Scotland. I guess for my first enabler will not be very surprising, and that type of significant new economy will require viable business models. That's for low carbon hydrogen production, both green and blue. And for blue, it also involves CO2 infrastructure, but also the remaining of the supply chain. The good news is that BEIS is already making good progress on CCUS and hydrogen business models. I'm not sure if all the participants are aware of this, but BEIS has published their response on the potential CCUS and hydrogen business models consultation quite recently. And they've highlighted their promising and potential business models for different parts of the CCUS chain, including CO2 infrastructure. However, the conclusion and finding for low carbon hydrogen production was that there is not yet consensus on the most promising option, and further work is needed. So I guess that's an important action for the UK government to clarify how the model could work for low carbon hydrogen production. I guess that's going to be a kind of important aspect of this first enabler, the viable business models for hydrogen production and rest of the hydrogen supply chain as well. I guess secondly, we can talk about the supply chain requirements. I think Mark's presentation was really good, highlighting that hydrogen production is only part of the overall supply chain. Within the overall hydrogen supply chain, we expect hydrogen pipelines, storage, industrial appliances, domestic appliances, and in use in transport, etc., etc. So again, BEIS is making good progress on developing some of the technologies. But you may have seen in Silvian's slides that this rapid rollout of hydrogen technologies and the whole supply chain will require significant supply chain across the full supply chain, hydrogen supply chain, to be in place on time to be able to make this work, because otherwise we may not be able to find the right people, right companies, and people to deploy those important technologies. I guess the third one is really relevant to link to the second one, the supply chain, but I guess more specifically, skills are really important as well. Silvian already mentioned this in his presentation. Luckily, Aberdeen is in a good position with the extensive oil and gas skill set there, and especially the CCUS one and partly the hydrogen skills required are quite relevant to the oil and gas industry. So some of the skills can be transferred to the hydrogen economy and the CCUS infrastructure. However, that won't happen on its own, so some upskilling will be needed, and there may be some specific gaps as well in terms of the skills required. For example, when we discussed it with some project developers in other studies, they did mention quite specific areas like hydrogen pipelines. If you need new hydrogen pipelines, that's not as straightforward as deploying gas infrastructure sometimes, so you may need some different skill set to be available on time within the UK. So we work with the Engineering Construction Industry Training Board on this topic before, and yeah, they're also working on this as well as UK government, but that's going to be an important aspect of this whole transition, energy transition, especially the hydrogen economy. There are others as well, but I don't want to use the whole Q&A session time, so hopefully that was a good starting point. Thanks
very much, Emrah. All right, now we know you're not in your pajamas, we can click you off the screen. Okay, I've got a couple of questions have come in, so I'm going to try and wrap them into one. Mark, these are directed to you. Is it possible to just say a little bit more about probably I would imagine the Hy4Heat project, and really what the UK government are doing to try and progress the safety case for hydrogen? Have you got some more information about how that's going and how that safety case is developing?
Thank you, Kirsty. So that is a very multifaceted programme where we've looked at everything from gas standards to appliance standards. So we've done a huge amount of work with a large community, everything from GDNOs to NPL to smart meter companies. So we've tried to bring the whole thing forward of what it would be like to deploy hydrogen in the home. So far it's going very well. We have appliances, we have prototype appliances that we're already testing, and we'll be going for safety testing next spring, and we'll be ready to start deploying them in demos from next summer. On the safety case itself, we've been engaging with the HSE since March this year. That continues to go well. We've done a huge amount of experiments with Steer Energy and DNVGL, and we now understand much better the behaviour of hydrogen in the home. And while what we found and are concluding is that hydrogen can be made as safe and arguably safer than methane in the home, there are some additional devices we need to put in, mainly centred around excess flow valves. So one of the challenges with hydrogen, it is an explosive gas, just like methane. We just need to be a bit more careful that we respect its properties and manage the flow in the home so we don't allow high concentrations of hydrogen to build up. So we've built that into the safety case. HSE are interested in it and positive about it, and hopefully in the spring we'll get a response from them and no objection to proceed to a trial. So that's going well. The other thing, just touching on Emrah's point, is we found as we proceeded with the work, there's more and more to be done. So one of the initiatives we're doing is working with EU Skills to design a training program for installers of hydrogen equipment. So it's important that hydrogen, as I've just said, is in some ways a similar gas to methane, but in other ways it's quite different and it needs to be treated differently. And it's very important that we've qualified people able to handle it and able to manage leaks, etc.
Brilliant, Mark, thank you so much. Tim, I've got a couple of quick fire questions for you. So I'm going to fire them at you all at once. The first one is, for the transport of hydrogen, are you going to be looking at new assets being installed, or are you only looking at using existing feeders? Also, how suitable are the existing oil and gas pipelines in the North Sea for hydrogen transport? And if you can multitask, can the NTS accept more than a 2% blend of hydrogen?
Okay, thanks, Kirsty. So in terms of, are we only looking at existing feeders. No, so our current concept select study is looking at both existing assets. So, for example, the NTS feeders and also the onshore Miller pipeline to Peterhead Power Station. But we are also looking at new assets. So, for example, the Aberdeen Vision pipeline that I mentioned earlier would be a new asset. So the second question was around the suitability of the existing pipelines in the North Sea for hydrogen transport. So we will not be looking at using existing offshore pipelines for hydrogen transport. We are looking at using them for CO2 transport, and there's a comprehensive inspection and engineering assessment ongoing to assure that those pipelines are fit for purpose. And the final question around can the NTS accept more than 2%? So the current gas standard management regulations only allow for a 0.1% inclusion of hydrogen into the gas grid at the moment. So BEIS have a working group of gas experts who are driving a three-step program to enable a change of the GSMR. And as Mark said earlier on, there are various projects to build the safety case to support that change as well. So yeah, no. So the aim is to be starting with 2% into the NTS, an initial 2%, with the ambition to increase that over time, which we would need to do in order to achieve a sort of net zero compliance for the UK.
Brilliant, Tim, thanks very much. Just a quick clarification question to Silvian. Did you consider cars and vans before HGVs?
Yes, exactly. So our analysis that is detailed in the report considered all modes of transport. So we have cars, vans, trucks, and buses. And I think we also consider demand for hydrogen in the shipping industry, also because Scotland has quite several ports where hydrogen can be used for long distance shipping and bunkering, basically. So we considered all sectors and vehicle types for transport.
Thanks, Silvian. And maybe just to share it out, I'm going to ask Emrah. This one's I'm not very sure about this question. So they've asked about comment on competition from ammonia production, and should we see hydrogen versus ammonia, or are they interchangeable? Is that something that we can comment on?
Yeah, good question. I mean, we are seeing ammonia as a, there are different ways to look at this. I mean, certain project developers see ammonia as a way of storing hydrogen, so you can produce, ammonia and then, ship ammonia a bit more efficiently than, shipping hydrogen, for example. So that's why some project developers are interested in production of ammonia. Secondly, there's already demand for ammonia, obviously. So there may be a way to replace some of the kind of low carbon, the existing ammonia demand with low carbon ammonia, so that may de-risk some of the operations. But I don't think there's going to be competition between hydrogen, in my opinion. I guess this is just an additional option for hydrogen producers to produce ammonia if they think that adds value to their project, especially for exporting hydrogen to other regions. But happy to get further thoughts from other panelists as well if someone disagrees.
Emrah, I'm going to not allow that, if that's okay, because I've got a million questions that I'm trying to get through.
Of course, yeah.
I'm going to fire this one. It may be our last question to Mark. I've had one coming in asking, it is likely that kickstarting a hydrogen economy, so the Aberdeen vision that you heard from Tim, is going to require significant infrastructure investment in hydrogen transmission. Does the UK government have plans to make available funds for this, similar to the recent announcement of the 800 million for CO2 transport and storage infrastructure commitment? Mark, are you comfortable to give an answer to that one?
I am, but I need to be careful because the Chancellor, the Exchequer, may have a different view. So at the moment,
all caveats required.
We are working hard on our spending review submissions, so I can tell you that BEIS has made a bid for significant investment both in hydrogen, but also in CCS, which is key for blue hydrogen. We do see blue hydrogen as very important to get this hydrogen economy started, and then longer term, we'll be looking to bring the green hydrogen once we've got it to scale and perform at scale. So the answer is yes. Unfortunately, it is now going into the hands of the Treasury, or fortunately, I should say, and hopefully they'll make the right decisions. But I can tell you that we've had very good feedback from Treasury, a lot of interest from Treasury, and also particularly from number 10, that we do something in hydrogen and that we stop talking about it and start deploying. So I'm quite excited about it, but unfortunately, the answer is watch this space.
Okay, Mark, I think that's a brilliant note to end on. So thank you so much. I want to give a huge thanks to all of our presenters, our panelists, and the people who have been frantically working behind the scenes to make sure that I don't mess anything up. Thanks to everyone, and thanks especially to everyone who's taken time out over lunchtime to come and listen in. There has been actually tons of questions coming in, so I haven't been able to get through a lot of them. I would say there is lots more information on our website and you can download the report. Emma, if you don't mind moving to the next slide to let people see the contact details. You can download the report using this link. There's also visit the website and you can find out some more generally about the project, and there's links to the Aberdeen Vision project. There's been quite a lot of questions coming in about that and when that's going to get started. If you've got burning questions that you really want answered, please drop us an email. We'll do our best to get back to you as promptly as we can. And sign up to the newsletter would be my other recommendation. So there's a link there as well. I've had a couple of really interesting questions coming in from people who are off grid and wanting to understand more about accessing hydrogen via tanker. So maybe if you are one of those people or you're looking for some specific information, then drop us a note with your contact email so that we can get back in touch. Other than that, just to say huge thanks to everyone, and we'll sign off. Enjoy the rest of your Friday afternoon. The slides, the report, the webinar itself has been recorded and it will be available next week on our website. I've had a couple of people asking about access to the slides. I can probably organise that if you want to drop me a note on that comms@theproject.uk, then we can look to try and do that for you. So thanks again to everyone, and we'll look to enjoy future communication about Acorn Hydrogen and the impacts that it's going to have on net zero. Thanks everyone. Bye.